All right, here's an example of section 1.4, number 78. If you want a further example of this, in your textbook, example number 5 of this section is doing the same thing, and so we'll follow that. So in 78, what they tell us, what's given in 78, is that the cosecant of the angle is equal to -3, and they also tell us that the cosine of the angle is positive. Now, why would they tell us two things? Well, it's because when you go around the quadrants, all students take calculus. If we focused on just cosecant being -3, if you remember, cosecant is the flip of sine, so it would have been negative in quadrants 2 and in quadrants 3. I'm sorry, in quadrants, I said that wrong, in quadrants 3 and in quadrants 4. That's where cosecant's negative. So what does this piece do? It lets us know which of those two quadrants we're in. And so because the cosecant is negative, and again its flip sine then would be negative, but the cosine is positive, we have to be in quadrant number 4. So you'll see this happen maybe in an example that I worked, but you'll also see it worked example in example number 5 as well as the videos. But this is a very specific I wanted to answer this specific question that's here. So we use these two pieces of information to determine the quadrant. Again, we did that by knowing that the cosecant was negative, and cosecant is the flip of sine, and we found out that they gave us that the cosine was positive, so we must be in quadrant 4. That's the only time those two things coincide, as in the lecture notes. So let me erase this decision maker. You can back up if you needed to see it again in the video. And so we've just decided we're in quadrant number 4, and so let's draw a picture. Pictures will help us with everything. And so we're going to draw a picture that's very similar in nature to something that you would see in example number 5. Going back to see what their picture looks like in that one. Yep, they have a second quadrant. We have a fourth quadrant. So let's go ahead and draw our angle. It doesn't matter where it is, but we do know it's a fourth quadrant angle. And we're going to look at this angle, and what we know is that it's got an x and a y. So this is the point x comma y, and it's got an r. Now we can use, I'm actually not going to refer to this as being the angle. This is the terminal side of this fourth quadrant angle. That's what they're doing in this section. And so I'll do the same thing. But it's got an x distance, and it's got a y distance. Now we're going to know some of those. What we know is that the cosecant of theta, they sneak that c in there, is equal to -3. So let's remind ourselves what cosecant theta is. I could flip back in the book. I could have it memorized. Ideally, you have it memorized. Cosecant is the flip of sine. Sine corresponds to y's. And so when you have the cosecant, you have the r over y relationship. I was flipping back in the book to see if they brought that up in this section. I don't think so. They are utilizing it, like when you look at example number 5 and others, but they're using the r over y. Now, what section was that in? Those definitions appear on page 22 in your text, right, that you have an e-copy of, and we are looking at the very top of that for the r over y. That's where you can find it. Page 22, right? You'll want to memorize that, cosecant being that. So here's what we know. The only way this could work out, or it shouldn't be the only way, I apologize, but a way is for r to be 3, r can never be negative, and y to be -1. So remember, your r is always positive because it's the distance between the point and the origin. And it makes total sense that your y is negative because look at it. So let me highlight that y in red right there. And I'm going to come in here with the red pen, and first of all I'm going to erase the y, and then I'm going to come in here with the red pen, and we absolutely know this is -1, and we know that this r is 3. So hopefully that makes sense. R is always positive, but look, that's a negative y distance. Of course it's -1. Perfect. You know the Pythagorean theorem, so you can figure out x, right? Since pre-algebra, we've been using the Pythagorean theorem. So what do we know? We know this desired x squared plus y squared is equal to r squared, right? X squared plus y squared equals r squared. You can use the books r is equal to the square root of x squared plus y squared. So again, the books would say r is equal to the square root of x squared plus y squared. We have the same thing. In this case, r is 3, and x squared and y squared is -1. And if you squared both sides, you'd have exactly what we have over here. So this is where we'll work from. So x squared plus 1 is equal to 9. So x squared is equal to 8. And we take the square root of both sides. And we know that you know from both beginning and intermediate algebra how to simplify a square root. And we have technically plus or minus the square root of 8. I'll step through it, which is plus or minus 2 root 2. Now, it's not going to be plus or minus. It's going to be one or the other. So let's take a look at our x. So I'm going to highlight that x in blue. So here's our x distance. Is that a positive x distance or a negative x distance? That's a positive x distance, right? So we can see that that's a positive x distance. So we are not taking the negative. We're taking the positive result of both of those. And so what x is x is, x is equal to positive 2 root 2. So you've done all of that to figure out, now I know it. I know from section 1.3 that sine is y over r. So what's my y? -1. What's my r? 3. Not shockingly, it is the flip of cosecant. What's cosine? Well, from 1.3 they defined it as x over r. What's that? 2 root 2 over 3. Awesome. And I'm going to just translate this picture down here so we don't lose it. Right? So we had this picture that we ultimately decided this was -1, this was 2 root 2, and this is 3. So now I can just refer to that picture. Tangent of theta is equal to y over x. How do I know that? Because I took the time to memorize it from the last one. I can also remember that tangent sine over cosine from this 1.4 section. And remember that it's y over x. And so if it's y over x, what's my y? -1. What's my x? 2 root 2. Obviously you can't leave it like that. So showing every step, right? So this is intermediate algebra, what we're about to do here. I'll do it in different color. Hit top and bottom by root 2. So they are not going to, well, let me tell you what they are going to do. They're going to assume that you know all your work from the previous class. Root 2 times root 2 is 2. 2 times 2 is 4. And we get a nice -√2 over 4. Cosecant theta, I just remembered that cosecant theta we already knew. That was what was given to us. But let's just find it another way. What's taught in this section is it's the flip of sine. So we'll get -3. Secant theta, we didn't know. And so that's the same -3 that they gave us. So that should have happened. Secant theta would be flipping over cosine, or 3 over 2 root 2. Again, we have to rationalize. So I'll show that process again. And top and bottom by root 2 and get 3. Let me switch back to black. And get 3 root 2 over the same 4 again. And then tangent theta, cotangent theta would be the flip of tangent. How do I know it's the flip of tangent? Because they gave us those relationships here in this section, I believe. Yes, on page 29. They talked about how each one's the reciprocal of these last 3 are reciprocals of their corresponding one above. And so if I look for tangent, it's negative root 2 over 4. So this is going to be -4 over root 2. and I'm going to multiply top and bottom by root 2. And so I'll do that in blue again. So I get a root 2, go back to black, just so you can see what I introduced. And this is negative 4 root 2 over 2. And so this is negative 2 root 2. Right? A nice simplified version of that. So that's how you do 78. If we recap for a minute, they gave us some information, and the first thing that we need to do is utilize that to know what quadrant we're in. The reason why we want to know what quadrant we're in is that gives us the right signs on the x's and the y's. R is always positive. So knowing that we were in quadrant 4, we drew a picture putting in what we knew. Because cosecant was equal to 3 over negative 1, we knew r, and we knew y for a particular point on that line. So we put those in. We put y in and r in, and we used the Pythagorean theorem, a nice old skill, in order to come up with 2 root 2. Knowing that triangle, which I translated down here, we're just using the definition of sine, cosine, tangent, cosecant, secant, and cotangent to just stack the numbers and rationalize denominators. It's that nice. All right. Hopefully that helps you out with this particular problem.